Start recording. Anyone got any questions they would like to ask? Yes. 32? All right, number 32. Which of the following solutions will have the greatest concentration of H3O plus? First of all, what is H3O plus called? Tell your partner. And if you did not just tell your partner, then you might get that wrong if you're asked that on the test. So tell your partner, what is the name of H3O plus? Hydronium. Okay. Now we want the greatest concentration of hydronium. What's another way that we could write H3O plus? We could write it as H plus. Those two mean the same. So we want the one with the highest concentration of H plus. Do we want a strong acid or a weak acid? Strong acid, because remember, strength matters more than concentration when it comes to how much H plus you get. Do you remember when we had the strong acid and we had to dilute it like 1,000 times to make it even close to the concentration of the weak acid? Okay. So we want a strong acid. So choose your strong acids there. Is A a strong acid? No. Is B a strong acid? Yes. Is C a strong acid? Yes. And is D a strong acid? No. And you can look those up on your table, okay, if you didn't get that. And now, what's the only difference between these two? We have concentration, so the concentration of HCl is 0.1, the concentration of HNO3 is 0.15, and so that one will have a higher concentration of H+. Is it HCl just stronger than H? What do we know about the strength of all the acids which are strong? All of them go to completion. There is no difference in their strength in water. If you have a different solvent, you might be able to distinguish between them, but in water, if you're stronger than H3O plus, you're just strong, and there's no difference in strength. Okay, HClO4 is the same strength as HNO3, as H2SO4. They're all the same strength. They're all strong. You cannot dissociate more than 100%, and they all dissociate 100%. Is good? Cool. All right. Next. All the rest of you got all of them correct, and you have no questions. Christina, yes. 29, excellent. Okay, so we have water at 25 degrees Celsius, has a pH of 7, that's at 25 degrees Celsius, and the equation for the dissociation is blah, 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 blah. And we have a heat term here. And now we know that we are at 80 degrees Celsius. So what is going to happen to this equilibrium if we go from 25 degrees Celsius to 80 degrees Celsius? So we've raised the temperature. And so what will happen now? It will shift to the right. Okay. So what has happened to the concentration of H3O plus? It has increased. And what has happened to the concentration of OH minus? It has increased. So what can you say about the H3O plus and the OH minus relative to each other? They are the same. So the H3O plus is the same as the OH minus. If that is true, which options can we eliminate? Tell your partner. If H3O plus and OH minus are the same, we can eliminate option A because it's not basic. We can eliminate option B because it's not acidic. So we do know that it is neutral because those two are equal. And the question is the pH greater than 7 or is the pH less than 7? And if hydronium has increased, what does that mean in terms of pH? pH has, tell your partner, what happens if hydrogen goes up, pH goes down? So pH is no longer 7, it's going to be less than 7. Did that make sense? Cool, good question. Yes.
But didn't hydroxide also go up?
Yes, but pH is related to, it is the negative log of hydrogen. It does not care what the concentration of hydroxide is. So what will happen is, let's just give ourselves a number. Let's say pH is equal to 6, okay? You're not going to get 6 because we can't shift that far, but let's just pretend. Okay, say pH is 6. That would mean that pOH is also 6, which means that pKW would be 12. Yeah? Did that make...
Yeah, so if it asks for the pOH question,
it would be less than 7 also. Yeah, yeah, perfect. Yes? Written number 6. All right. Okay, so we want to compare the ease with which the first hydrogen is removed from a diprotic acid. What I would like you to do right now is I would like you to write the formula of any old diprotic acid, any diprotic acid you want. Pick one. And if you're not sure where to pick one from, get your table out. I should see a pink paper in front of everybody. If you don't have a pink paper, you need to come and get one. Okay? Grab one for him too. Just bring it. Okay. So you should be on your pink booklet on page 6. Go find a diprotic acid. Raise your hand if you have found a diprotic acid. Okay, most of you have. If you have not, you could choose H2SO4, you could choose H2C2O4, and you could choose H2SO3. Is good? Okay. Now the question says, and there's a whole bunch more down below, but I'm just going to go with those three because they are all on the same area. What does it mean, the ease with which the first hydrogen is removed? What does that mean? Try to explain that to your partner and comparing that with the ease of removal of the second hydrogen. See if you can explain to your partner what that means. What would the removal of the first hydrogen look like? Not rocket science, like literally easy. Remove one hydrogen. What would that look like? What should one of our products be? H plus. And let's just assume we're using a weak acid. Should that be a one-way arrow or a two-way arrow? Two-way arrow. Okay. H plus, and what is our other product? HA negative. That is the first dissociation. That is the removal of the first proton. Yes? First dissociation. What would the second dissociation look like? The removal of the second hydrogen. You would have HA negative, equilibrium arrow. Now, everyone, fill in the rest of it. Who are the products in that second one? H plus and A2 minus. Excellent. Now, I want to know, is the blue hydrogen easier? Does it come off more easily? Or does the yellow hydrogen come off more easily? Or do they both come off with the same easiness? Tell your partner what you think. Which one is easier to come off, or are they both the same? And if you're having trouble picturing that, go and find an actual example. So instead of H2A, maybe try H2SO3. And then you can look at HSO3 minus. Now go find those on your table. Those two. H2SO3 is there. Where is HSO3? Further down. Where the heck is it? Somewhere way down here. Why am I not seeing it? I'm just blind. HSO3, here it is. Okay, okay. So we have H2SO3 and HSO3. What other information do we know about H2SO3 and HSO3? H2SO3 is what compared with HSO3? It is stronger because it's higher up on the table. Also, take a look at the Ka value. This is going to be good in terms of actually strengthening your argument. Yes? Ka, 1.5 times 10 to the minus 2. This one down here, 1 times 10 to the negative 7. Okay, so let's pop back here. Whoops, sorry. So the Ka, 1.5 times 10 to the minus 2, and this one is 1.0 times 10 to the negative 7. What do those values tell you? They tell you concentration of products over concentration of reactants, right? And what is H plus? H plus is a product or reactant? Product. Crazy pen. Product. Product. Was the removal of the first H easier, harder, or the same as the removal of the second H? First one was removed more easily because you get more product. Yeah? Right? Larger value. More product. And since H plus is a product, the H plus came off more easily. Is that making sense? Yeah? Good. Did you have a question? How do you notice what? How do you notice? Because you say it's stronger, therefore it dissociates more. Yeah. Stronger acids dissociate more than weaker acids. Okay, the position of the equilibrium sits more to the right. Okay, so the stronger the acid, this is good stuff we're getting at here. The larger the Ka, the more the equilibrium sits towards the right. Sorry about that. Does that clarify for you? Good question. Good question all around. I'm glad that one got asked because there's a lot of stuff going on there. Yes?
Would another less good explanation be that it's more complicated, like the formula for it is more complicated, or names that are, or products that are like bonded, so it will come to
No. No. If you wanted to argue in terms of, say, charge, it's going to be harder for a positive ion to leave a negatively charged species than it is for a positive ion to leave a neutral species, because that negative charge will hold the positive more strongly. You could argue it that way. But mostly, like, I'm thinking, if this question came up, probably you would be expected to argue it either in terms of Ka or just in terms of strength of acid, and say a stronger acid dissociates more completely and therefore the H plus comes off more, and therefore the first one comes off more easily. Yeah? Yes? 57, multiple choice? I guess there's not 57 written response. 57, multiple choice. Okay, consider the following equilibrium. What changes occur to the H3O plus and the pH when we add NaOH? So when we add NaOH, number 57, what does NaOH do when you put it into water? It dissociates into Na plus and OH minus. Do we care about one of those ions or both of those ions when it comes to this equilibrium here? Tell your partner, is Na plus going to have any effect on the blue equilibrium? No. Is OH minus going to have any effect on the equilibrium? Yes. Okay. So if we have now increased the concentration of OH, which is what we've done, okay, so we added NaOH, therefore OH minus increases, that's our stress. What will we have in terms of a shift? We will shift to the left. So what is going to happen to the concentration of H3O plus? H3O plus will, if we're shifting left, is that an N or a D? D. Sorry, I wasn't able to hear you guys. I'm like, they're saying something increases, but I just don't know what they're saying. H3O plus decreases during the shift. So what will happen to our pH? pH always goes the opposite direction of hydrogen, so pH increases. And so that's going to be H3O plus decreases and pH increases. That is option C. Yes?
NaOH is added though, like, how do you know if it's added to the products react?
It doesn't matter because it goes into the beaker. There are no products. There's no like section of the beaker where the products are and where the reactants are. Do you know what I mean? Like if we're here, here's our beaker. Floating around in here, there's water. Okay, there's like a billion waters. I'm not going to draw any more than that. Okay. And then every once in a while, there's a little bit of H plus and OH minus, yes? When I add in my NaOH, Is it possible for me to add it to the products? No, it goes into both because both are in that container. So it just goes into the reaction vessel, and both reactants and products are present there. Yeah? Good question. Yes. 11 written? Yep. 11 written. Okay, first of all, do we know the meaning of predominant? Predominant. Protruding. That's like more like prominent. Okay, so that's probably one of the first things we need to address. You will hear this word often in chemistry, so it is worthwhile learning. The word predominant. What just happened? Hang on. Ah, sorry. Predominant means main. Okay, so anytime you see the word predominant, if you get flustered by it and you're like, oh my gosh, Ms. Spence told us, but I don't remember, you can ask me, okay? If you're on a test, you can ask me, but it just means main. So what is the main reaction when HC2O4 is mixed with HSO4 minus? So who should be the reactants in our reaction? It's not difficult. Who are the reactants? The things that are there. Yes? Yes. So we have HC2O4 minus plus HSO4 minus. Now, what do you notice about these two things? Maybe they're both amphiprotic. Let's check, shall we? Okay, let's go and look at HC2O4. HC2O4. There we are. Okay, HC2O4. And HSO4. HSO4. Okay. Okay, so HSO4 is up top. HC2O4 is down below. So who will act as the acid and who will act as the base? HSO4 will act as the acid. So let's go here. Okay. This is the stronger, and this is the weaker. And so what that means is that this one will act as the acid, and this one will act as the base, which means now I'm going to cross this out because I don't want to be looking at that anymore. Yes? And I'm going to say, okay, now I have that. Could you then predict the products of this reaction? So we would then have H2C2O4 plus SO4 2 minus. Justify your statement by comparing Ka values. Well, you could say, okay, my Ka value for HSO4 is, I mean, if you weren't asked to justify it, you could just say it was a stronger acid. But because you are asked to justify it, 1.2 times 10 to the minus 2, 6.4 times 10 to the minus 5. 1.2 times 10 to the minus 2, 6.4 times 10 to the minus 5. Okay, and that's our Ka, and that's our Ka. Since, now practice writing a sentence here, because mostly, one of the things that most Chem 12 students struggle with is writing a coherent sentence. Yes? So try writing it now, and then you'll compare your answer with mine. Okay? You can start with since, or you can start some other way. Once you have written your answer, trade with your partner and read theirs and see which one you like better, or if you have any constructive criticism for them, if you have anything you could help them with. So swap papers. And I'll tell you what, I'm actually going to recommend that in chemistry, when you can write in point form, that you write in point form, okay, rather than in paragraph form, because it means you don't have to have as many words in between, and it means that you're less likely to garble up your words and like get things in the wrong place. You know what I mean? Like sometimes words just go in the wrong place. So point number 1, what would we like to make point number 1? Ka of, hi, thank you. Yuri is not here.
Thank you. HSO4
Ah, Ka of HSO4 minus is, oh, you know what we could do? Like, let's assume we hadn't written them up there.
Okay.
1.2 times 10 to the minus 2. Ka of HSO4, and there it is.
And Ka
Is greater than. Let's just get right to the point. Is greater than what?
HK of HC2O4 minus, and then like, you know,
HC2O4 minus, and that is 6.4 times 10 to the minus 5. Therefore, what can you conclude from that? HSO4 is stronger What about it? How is it stronger? In what sense? It is the stronger acid. And therefore, HSO4 will act as the acid and HC2O4 minus will act as the base. Yes? That's it. Yes. Okay, we're going to work on writing answers clearly and coherently, point form, because that way, like I said, you're less likely to get words to get in the way of your answer. Okay, so we have 3 points here. 1, 2, 3. Okay, Ka of this one's bigger than that one. Therefore, this one is the stronger acid. Therefore, the stronger one acts as the acid and the weaker one acts as the base. Done. Boom. So that's part B. What? Number 2 should do. Or you could even skip number 2 and just go straight to number 3. Yep. Okay. Depends on how many marks the question is. If it's 2 marks, I would just do that. If it's like 3 marks, I might be like, okay, I'll throw that in. You know what I mean? That's the other thing too. Look at how many marks a question is worth. If a question is worth 1 mark, you don't want to be writing some big long paragraph. Chances are you're going to throw something in there that's wrong, and I'm going to be like, oh, I'm so sorry. This was good, but that's wrong, and I cannot now give you full marks. Yes? So, but if it's worth more marks, you do want to say a little bit more. Now, identify a conjugate acid-base pair. Whoa. Sorry, it went jumping around on me. So in our reaction here, show your partner a conjugate acid-base pair. And if you are on your phone, what the hell are you doing? Just saying. How many people think they've identified a conjugate acid-base pair? 2/3 of you. Oh, 3/4 of you. Okay, you could either write what? You have a choice. H SO4 minus and SO4 2 minus. That's option A. Now, if it says identify a conjugate acid-base pair, do you want to write 2 conjugate acid-base pairs? No, don't do it. If it says a conjugate acid-base pair, just give me 1. Yes, don't go answering questions that they have not asked you. Just stop writing now. Okay, your other option, option B, would be HC2O4 and H2C2O4. Now, do you guys know how to figure out whether the products or the reactants are favored at equilibrium? Yep, go do it. Tell me. Okay, figure it out.
It's kind of my favorite. Still be curly. That's So. There. Just some of those is so yeah.
Now remember, this one also says explain, so unlike on your quiz, you would need to justify it with some words. Yes? So like if it says explain, then you would need to write like an explanation. If it doesn't say explain, then you just write reactants or products or whatever. What do you guys think? Reactants or products?
Yeah.
Reactants, okay. And all you would need to say is that the acid H2C2O4 is stronger than who? HSO4 minus, yes. SO4 minus. Okay. And what now? Therefore, I can get rid of the if you don't like it. Doesn't have to be there.
Like, the product side is stronger, and then that's that.
The reverse reaction is favored. Could we say that? And therefore, reactants are favored. Yes? Yes. Excellent. You guys rock. Nice job. Other questions? If you don't have more questions, I can just give you time to work. Want just time to work right now? Yeah? Okay.